Hi class, we need to take a look at example 4. Now, example 4 has a very specific type of inequalities. These are called compound inequalities because you will have the actual variables or the unknowns in the middle, and then they technically have two conditions embedded in one. So in terms of a graph, you're going to have a min value all the way to a max value. And in terms of the inequality with the unknown statements, you're going to have that the unknown, it's bounded above by a value, in this case 7, and then also bounded below by another value. In this case, you read it as 2x plus 1 is less than 7, and 2x plus 1 is greater than negative 3. So in any case, you end up with a min value and a max value for the inequality. Now, let me erase all of this, and the process of solving this, it's not as complicated as what we've done before. So the basic idea here is the following. We're going to be doing operations to isolate the variable in the middle, but whatever we do to the middle, you also have to do it to the edges. So for example, to isolate the 2x, we would subtract 1, but you have to subtract 1 from all parts of the inequality. So after subtracting 1, we would end up with a negative 4 less than or equal to 2x less than 6. And then we would divide by 2, divide by 2, divide by 2. And then at this point, we would end up with negative 2 less than or equal to x and less than 3. This particular one is only asking for us to solve. So let me just write it as the solution. It's going to be that the unknown bounded by two values. At the lowest value, you're going to have a negative 2 less than or equal to x and less than 3. So all the values that satisfy the original statement are values that include negative 2 and any value less than 3. Let me just check the algebra. 6 and then 3, negative 4, negative 2. That's it for problem 1. Let's move on to problem 2. Okay, problem 2 actually has a y as a variable, and they also want us to express a solution with interval notation. Notice that the previous one only wanted a solution, so that was it for this one. It didn't want the interval notation or the set builder. And in order to solve this one, let's start by adding 3 to all parts of the inequality. So technically plus 3, and plus 3. This is going to give us on the lower bound 0 less than or equal to 6y and less than 15. And then at this point, we're going to be dividing by 6, and dividing by 6. So our inequality, it's going to be 0 less than or equal to y and less than 15/6. And let me rewrite as the solution. Once again, 0 less than or equal to y and less than 15/6. The interval notation, well, in this case, bracket on the lower bound, since you're including the lower bound, but you're not including the upper bound, so 15/6 with an actual parentheses. Remember, the parentheses means you're not including the upper bound. Brackets means you're including the upper bound. So if it had a less than or equal, brackets on those. If it just had greater, in this case, I'm reading it as y greater than 0, you would have a parentheses, but we're going from 0 to 15/6. That's actually it for the first two problems. I'll put the other ones on a different video.